All right, students, what you see before you is a beautiful drawing of the world. We've got the North Pole, we have our equator, and we have our South Pole. These lines that I've drawn here are the lines of latitude, and they separate the different climate zones. So if you remember from when we did climate, the zone right in the middle, these red lines, this is all the tropical zone, which means that they have the hottest year-round temperatures. The zones that are green on my globe right now are called the temperate zones, which means that they experience the most seasons. That's the zone that we are in. So you can see by our map, Maryland is like here. So we are in the temperate zone. And then these blue zones at the top and the bottom of the earth are our poles. That's in our polar zone, which means they are the coldest. What you're learning about this week is why. Why are these zones colder or warmer than others? The way I'm going to show you this is by using a flashlight. You can see. I'm going to be putting it onto the earth, and you should be looking at the size of the circle and how it changes with the angle of the sun. So what's really important here is that my flashlight is going to stay the exact same distance away from the earth at all times. The flashlight represents the sun, and the sun really doesn't change its distance from the earth. Does a tiny bit, but it actually is closer to earth during our winter. So that means that the distance from the sun doesn't have anything to do with seasons. So what it really is the angle that the sunlight hits us, which changes as we revolve around the sun. So please watch. We're going to show you right here the angle of the sun, right like that, on the equator. You can see the circle. The light is pretty intense. It's very bright. And the circle's pretty small. This is because the angle of sunlight is just about 90 degrees. The flashlight is hitting the earth at exactly 90 degrees. This results in higher temperatures year-round. Now I'm going to keep my flashlight the exact same distance, but I'm going to tilt it up so that it's hitting the poles. Compare that circle of light to the one on the equator. This light is much dimmer. It's spread out over a much bigger region. And so that actually results in colder temperatures. So you'll notice I'm keeping the flashlight at the exact same distance. And just by switching the angle can really change the intensity of light on the earth. I hope that model helped. Stop recording.